Take a moment to observe this figure. Do you notice anything special about it? It looks symmetric, doesn't it? But what does symmetry really mean? So what's the symmetry about point? Today we are going to explore central symmetry. Given point I, a transformation that maps point I onto itself and map each point M different from I to a point M prime, such that point I is the midpoint of the line segment M prime, is called a symmetry about center I. Point I equals the center of symmetry. A symmetry about center I is usually denoted by R sub I. If figure H prime is the image of figure H under R sub I, then we say that H prime is symmetric to H about center I, or H and H prime are symmetric to each other about I. From the definition above, we infer point M prime is the image of point M under R sub I if and only if vector I M prime is the process of vector I M. Consider triangle XYZ and a point I. Under the symmetry about center I, point X is mapped to a point D. This means that vector Ix is the process of vector ID, and point I is the midpoint of segment XD. Similarly, point Y is mapped to point E, and point Z is mapped to point C under the same symmetry. Therefore, triangle XYZ and triangle DEC are symmetric to each other with respect to center I. Symmetry can be observed clearly in graphs. In the coordinate plane OXY, symmetry about point play an important role, especially symmetry about the origin. Let point M have coordinates xy. Under symmetry about the origin, point M is mapped to point prime, whose coordinates are minus x, minus y. The origin O is the midpoint of segment M prime. This relationship gives us the coordinate rules of symmetry about the origin. X prime equal minus x, y prime equal minus y. Now consider a straight line passing through the origin. On this line, any point on the positive side has a corresponding point on the negative side, such that the 2 points are symmetric with respect to O. They lie on the same line, are at equal distances from the origin, and face opposite direction. Let M and N be two arbitrary points, and let M ram and N ram be the image under the central symmetry with center I. By definition of central symmetry, vector I M ram is the opposite of vector I M, and vector I N ram is the opposite of vector I N. Therefore, the vector from M ram to N ram equal the vector from M to N. As a result, the length of segment M ram N ram is equal to the length of segment M N. Hence, central symmetry reserves the distance between any 2 points. Consider a line passing through 2 points M and N. Let M ram and N ram be the image of M and N under the central symmetry with center I. From property 1, the vector from M ram to N ram is equal to the vector from N to N. Therefore, these two vectors have the same magnitude and the same direction. As a result, line M ram, N ram is parallel to line M N. In a special case where the center I lies on line M N, the image line coincides with the original line. Hence, a central symmetry maps a line onto a line that is parallel to it or coincide with it.